Hello, this is Simionescu presenting the paper Enhancing Computer Programming Skills to Engineering Students using Mechin 2D Modular Kinematic Subroutines. Mechin stands for Mechanism Kinematics in 2D. It's a collection of subroutines that I wrote over the year, was presented under this name in a conference paper at an ASEE2021 IDETC conference, and it's referred in the reference of the paper. If interested, you can find the copy, and there are links to animations of the various figure of simulations that you can see here. Okay, so this cartoon from Robert Norton's Design of Machinery, it's illustrative to the message of this paper, that engineers, they need to learn how to write code because they can expand their career opportunities. They can work with engineering software companies, or if students choose to go to graduate school, being able to write code, it's going to be helpful if their research is computational based. It's agreed that mechanical engineering students have fewer opportunities to practice programming after being introduced in an introductory class in their freshman or sophomore year compared to their computing science colleagues. So in this paper, we are presenting some computer programming exercises that students at Texas A&M University in Corpus Christi, seniors taking a mechanical systems design class, are doing. They have to download first the integrated development environment of Free Pascal, download the library of subroutines, and perform some exercises, two of linkage mechanism and a third one on discount mechanism synthesis. They have been surveyed, the students that went through or performed these assignments in spring 2021, about their perception, found these assignments useful, and those are presented, their perception and surveys at the end of the paper. The two linkage mechanism applications, a crank and then a crank slider mechanism. It's directly related to a semester project that they need to perform, and it has as a main mechanism a crank slider with a slider moving in a vertical plane. It's electric motor driven, this punch press, and students, they need to perform kinematic calculations, load force analysis, size or select the motor, size of flywheel, and then do some mechanical design of the main component, including the pinion shaft. Regularly, they use for their analysis Excel and working model 2D software. With Mechin 2D subroutines, they are in a sense duplicating some of the working model and Excel calculations that they are doing. Okay, so the first assignment, 47 lines of code. they receive this source code with comments, and some are just they need to fill in some to show their understanding of the source code, like what is XO and YO, these the coordinates of the crank about which the crank rotates. There is a the simulation occurs between so there is a do while loop, and they need to replace that with a for loop. So it starts here repeat until they need to change this to a for loop. In addition, they need to show their understanding of the source code and of the subroutines from Make-In2D's library. They need to change the crank length, and they need to change it from whereas square filleted rather than rounded at the ends. Here are animations of the what the source code has given to them. It's producing, you can see a meter that is measuring the crank angle and what you are expected to obtain after modifying the source code. Being able to visualize the mechanism in motion provides them with feedback and see the correctness of their modifications. The second assignment, it's a bit more involved. This second source code that is given to them, it simulates a crank slider mechanism offset, and the line of sliding is horizontal. Students need to modify the source code where the same crank slider mechanism has this time the slider moving vertically, same amount of offset. They need to change the subroutines that are producing the meter for the transmission angle, and also the slider displacement. The program also outputs an ASCII file, multi-column ASCII file that they need to use to produce some graphs. So simulation, animation of the what the original program is doing, and then what it's expecting from them to obtain with after modifications. And I mentioned the source code, or rather the data file, the ASCII file, and using that, they are produce plots of the slider displacement as function of input crank angle, velocity, and in red the acceleration of the slider, as well as the transmission angle, the curve in blue, and the in dashed red is the discriminant, the value of the discriminant that occurs when solving the kinematics of the slider crank. The program, or rather Make-In2D, it uses modular kinematics. So for example, in this case, we have the crank, and the crank is amplified with a ASEE group, a dyad rotation translation, and it returns together with the coordinates of the slider and the x and y derivatives of those x coordinates, the discriminant that occurs in doing those calculations, in kinematics calculations. So this discriminant It could be used as a performance parameter, same as the transmission angle. So you can see where the transmission angle departs maximum from the ideal value of 90 degrees. We have discriminant delta experiences low values, and around the ideal value of 90 degrees it has a maximum value. Okay, so this was the second assignment. The third assignment, it's about chem follower synthesis. And the first requirement is for the students to produce in Microsoft Excel the follower motion for translating and oscillating follower as specified for given follower program, and then to use that Excel spreadsheet to produce the chem profile as follower envelope. You see here sample outputs, and these come from AutoCAD. Their choices here is to use subroutines written in from Making 2D, or MATLAB code made available to them, or Octave. Octave and MATLAB are compatible to a good extent, with the difference that Octave does not read Excel directly, so they have to convert the Excel files to ASCII from where Octave reads the follower displacement, and likewise for Making 2D. So for this third assignment, as I said, they had a choice to use between Making 2D and Free Pascal, MATLAB, Octave. Here what you see not available, it means that they haven't performed the assignment fully. They did only the Excel part, but not the chem profile generation part. And so you can see that MATLAB was their first choice, and Pascal was done by a choice of 12 students. In terms of grade distribution for the 3 assignments, you see it here. So in blue is first assignment, 42 students out of there were 47 in class that they scored 90 and above, and then these are students that did not submit homework. And then for assignment 2, there were some lower grades, and assignment 3 there's even more spread, with only 3 that scored above 90. In terms of addition for their own self-assessment, we did this survey and with 7 questions, and we're asking them to assess their programming ability before the assignments. 2.4 out of 5, with 5 being maximum. Fully agree. And then remember, assignment 1, they had to change repeat until while loop to for loop, so it's above average, their perception of being able to or understand these structures, and of computer and graphics. Fourth question, ability to read and write from to a data file and from a data file, the highest 3.6 out of 5. And then the last 3 questions is about, or 5 and 6 questions, you know, if in the future they would be confident to engage in programming work, and or collaboration. And overall, they there was above average, slightly above average, their opinion that such assignments should be given to future students. From class evaluations, I have some comments, so are also anonymous, about the class and related to the 3 assignments as well as the project. As you can see, one student says, I like the fact that he had to or she had to use working model, AutoCAD, Pascal, and MATLAB. So some favorable comments. The more negative comments have to do with the need to download and install different systems which are not compatible with Mac, and then criticism about using Pascal, which is not a mainstream programming language. I disagree with the student saying that it's from the 1970s. Fortran is from the 1950s and still in use. But again, Pascal, free Pascal, is not as widely used like Fortran or C or Python. Okay, so this was the presentation, and if there are any questions, I'll be happy to take them live. Thank you.